Hello and welcome. Today, we are going to break down a fundamental concept in the world of chemical reactions: how to calculate turnover frequency, often abbreviated as TOF. In simple terms, TOF is a measure of how efficient a catalyst is. Think of it as the speed at which a single active part of your catalyst can do its job, which is converting reactant molecules into product molecules. Understanding this value is crucial for comparing different catalysts and finding the very best one for a specific reaction. The core formula to remember is TOF equals the amount of product formed, in moles, divided by the amount of active catalyst sites, in moles, all of which is then divided by the reaction time. So, the equation is TOF equals moles of product, / moles of active sites times time. The final unit for TOF is an inverse time unit, like per second, S⁻⁴1, or per hour, H⁻⁴1. Let's look at each piece of this puzzle. First, the moles of product formed. This is the value you get from your experiment. You would typically run your reaction for a set amount of time and then use an analytical technique, like gas chromatography, GC, to measure exactly how much product you've made. Second is the reaction time. This is straightforward, it's just how long the experiment ran, whether it's 60 minutes or 3,600 seconds. The third component, the moles of active sites, can be the trickiest to determine. For a homogeneous catalyst that is fully dissolved in a solution, you can often assume that every single molecule of the catalyst is an active site. However, for a heterogeneous catalyst, like metal particles on a solid support, only the atoms on the surface are active. To find this number, scientists perform special characterization experiments, such as chemisorption, which essentially counts the number of accessible surface sites that can participate in the reaction. Let's put this all together with a quick example. Imagine you run a reaction for 2 hours and produce 0.4 moles of your product. You used a catalyst that was determined to have 0.001 moles of active sites. To calculate the TOF, you would take 0.4 moles of product and divide it by the result of 0.001 moles of active sites multiplied by 2 hours. This gives you a turnover frequency of 200 per hour, 200 H⁻⁴1. This means that, on average, each active site on your catalyst was able to convert 200 molecules of reactant into product every hour. A higher TOF always indicates a more active and efficient catalyst, which is the ultimate goal in catalyst design. Thank you for watching this tutorial. If you found this explanation helpful and clear, please give this video a like and consider subscribing to the channel for more chemistry content. Make sure to hit the notification bell so you don't miss future videos. Your support truly helps us create more educational content like this. We'll see you next time.